Well, then let's get rolling. Hope everybody has this shared screen sharing up and can see the link to the session notes. Please go there. It's also in the chat box, the link to it, and insert your name. Follow along. Feel free to edit that. Insert text and comments in that document as well. So I'm curious if how many people are new to RDA or new to the Data Discovery Paradigms Interest Group. Our objectives are, as the name suggests, to enhance the ways and methods and infrastructure for discovering research data. That's a pretty broad scope, and we've narrowed it down to focus on particular topics in that domain, and we've actually been going now for over, well, actually we began at plenary number 18, which was September 2016, I believe, and it had a lot of activity through that time. So what we want to try and accomplish today is get reports from the on activities that are ongoing. Here, two presentations on the topic of user data search studies, analysis of how people search for data. This is a very interesting and evolving topic. So we'll get to insights into that, and then we'll have discussion session on how that will incorporate moving forward on the data granularity topic, and then on the user studies topic, and then discuss ideas for any new initiatives that the Data Discovery Paradigms Interest Group might help foster and initiate. So, well, that's the agenda, and I think the next well, order of business is the jump to updates from data granularity. But I think actually the next slide. Go ahead, Fotis.
Yep, I think that's me. So for those who are joining, so to follow up on Sirizoda's introduction, I think everyone can see the participants list. So I would ask, like in the next few seconds, to put a green yes for those who are familiar with the data discovery and RDA, with the data discovery group, first of all, and no for those who are first joined in the data discovery paradigm session, mostly so that we can have an idea of how new the audience is in what we're describing. So if you go to the participants list on Zoom, I see that we are 35 participants at this point, which is pretty awesome. And I'll ask you to click on the yes or the no. Yes, you are familiar with data discovery. This is not your first session. No, this is sort of your first entry on the interest group, and you, yeah, that's it. Thank you. I see, okay. I see a few yeses, quite a few no's. I'll give it a couple more seconds just to be on the safe side. But from my understanding, as far as I can tell, the no's are a bit more than the yeses, at least so far. So that's at least 50% of the group. So, which means that a short introduction on what we are aiming, what the data discovery group is aiming for is sort of in order. And before I start, my apologies, you might hear some noise in the back end, and I do apologize for that. So what is the motivation? So the main purpose of this interest group is to sort of aim on the findable aspect of the FAIR principles. As you can see here, these are the FAIR principles as defined. For the findable part, they are four key aspects here identified there. And here we are talking about metadata that are assigned a global and unique internally persistent identifier, so PIDs for metadata. The data themselves are described with rich metadata, so we can identify what it's actually about, and that the metadata are registered in a searchable resource, and that the metadata specify the data identifier. So these are how the FAIR aspect, the findable aspect of FAIR is sort of further detailed. The data discovery interest group focuses on F3, which is about the registering or indexing searchable resource, or to state in a more broad term, how to actually see the data discovery, how it works, what are the issues, what could be improved. So in the data discovery process, as sort of we handle it, we have three main sort of actors. We have the users on one hand, we have the data providers, and also you have the data catalog. A user has have their own needs, and so they have a particular way of interacting with any data discovery process, either directly through a data provider or through a data catalog or anything in between. Data catalogs usually rely on a data discovery service to provide this information to a wider audience. And data providers sort of need to identify and provide their own data, that they're curating, they're annotating, they're maintaining to a data catalog so that it's easily findable. So this is sort of the key components of a data discovery process. There are many details in between, a lot of issues, and sort of this is what we are trying to do here. Looking at the charter of the interest group, there are two main objectives. So the one is sort of to establish this sort of forum where everyone involved in that discovery process can sort of discuss, explore certain issues, and ultimately improve how data discovery works, both for users, for data providers, data resources, and so forth. On the other hand, despite this being a particular interest group, we also try to produce actionable recommendations. This recommendation can range also the spectrum of all different stakeholders in the data discovery process, which includes, again, data producers, data repositories, seekers, and data service providers. The key aspect and key element in all those points is that the ultimate focus of this interest group is the data discovery itself. Many different perspectives, but same process. So if you look at the progress of the interest group, I think this has been around for a bit over than 5 years. The kickoff of the interest groups was at P8. That was, I think, 5.5 years ago. During the kickoff and in between the plenaries, we sort of identified 4 main task forces. At that point, we're talking about guidelines for making data findable, use cases for data task collections, metadata enrichment, and relevance ranking. These 4 task forces continued across P9. And at P10, we actually were fortunate enough to have outcomes out of these 3 task forces. So just to put it again in a context, in an RDA context rather, the data discovery paradigm institute group is dealing with the process of producing outputs in a rather unique way. Instead of spinning off working groups in general, what we try to do is to create internal task forces that are hopefully a bit more agile in that context. And we try to produce these sort of supporting outputs. These 3 task forces, as I mentioned before, produce these 3 supporting outputs. They are already listed. One is about 11 quick tips for finding research data. The other one is about user requirements and recommendations for repositories, and also a survey about the current practice for data research services. So all of these are available and connected on the RDA website. Also, the DOIs are listed here for your reference. At that time, we also initiated 2 new task forces, a data discovery on granularity, which you will be hearing a few things in later today, and also another one about using schema.org for research data discovery. After this sort of 4 plenaries, we sort of continue on a monthly basis for all the task forces, the metadata enrichment, the data discovery, and the schema.org. Eventually, the schema.org migrated to a working group during P14, which was also the kickoff of the research metadata schemas working group, which is active at this point. Right now, we are hoping that we will start a new working group shortly. I'll pass this on to Kati in a bit. And basically, this is where we are right now. We have 1 active task force, 1 that is hopefully going to a working group. And one of the outcomes that we expect for today's sessions is to identify where there are particular new topics, new ideas, new problems or issues that would make sense to start a new task force under this interest group. So with that, this sort of concludes the introduction to the interest group. I know it was a bit short on that end, but with that, I will give the floor to Katie Mcneil, who is leading the task force on the granularity, and she will be giving the information about that. So
and yeah, I was going to say, or if you prefer to, I sent you the link to mine, whatever is easiest on your end.
I think it's easiest to share. If it doesn't work, I'm more than happy to do the going for you.
All right. So hi, everybody. My name is Katie Mcneil, and with Raina Jenkins, we are the co-chairs of the Data Granularity Task Force of this interest group. And Raina sends her apologies, she has a conflict, but I will be channeling her and all of her creative ideas. So I'm going to share my screen and just do a brief presentation. And some of this may be, so you should be able to see, hopefully my screen now that shows a presentation slide.
Yep, absolutely.
So again, this is just a briefing for the group, and there's a session tomorrow that I'll be talking about a bit more. So a bit of history, which is some of what Foti's already mentioned, is there has been awareness by a number of RDA members of the relevance of data granularity to a number of different realms, not only data discovery, but citability, metadata organization. How do you deal with data at various different levels of specificity, from collections to data sets to individual data points? And this is something that's a cross-cutting topic that touches on a range of different areas. So there's awareness that this is of increasing importance. And so as Foti said, they launched a task force within this interest group to look at data granularity. And that task force has been going for a couple of years, and there's been varied membership over time. Apologies for the creaking door in the background. With varied membership over time, and I list at the bottom the current task force members who have been working in this latest phase. And that latest phase, somebody kicked off the last RDA plenary about 6 months ago, where there was a session where people were encouraged to join up, to actively join the task force and to join an effort to think about, as Fotis was saying, turning that task force into a working group. But I neglected to note that the prior various iterations of the task force over time have produced their own documents, including a draft document on guidance for data granularity amongst not just a single player, but multiple players within that infrastructure environment that Fotis had mentioned. So where we are now, as I said, is we're thinking about we're proposing to launch a working group on data granularity. The proposal, I'll say this several times, I can't say it enough. Currently, Raina, who's in Canada, and myself, who are in the United States, are draft co-chairs. We would really love a third co-chair outside of North America. So I'm going to say that as many times as I can. We'd love to have you join the working group in general, and to join the leadership team of it, because diversity is really important to us. So overall, where we are is on the right-hand side here, this Fotis has kept this nice snapshot of overall the endorsement process for new working groups. And we're within box 1, interest group or working group, draft a case statement. And we're within that box now seeking informal feedback on this. So the case statement is linked from these slides, is linked from information about our session. And we would really like to have informal feedback on that first version of the draft to talk about what would the working group tackle within the 18-month period. So the way we're looking to solicit that feedback is in the rest of today's session, in our discussion groups. We have a dedicated Birds of a Feather session tomorrow at Breakout 7 time, and that will be dedicated to discussing the issue and discussing the case statement. And then we'd love to solicit further informal feedback through November. So that's within this one box. And then the next phase would be the formal review and feedback phase within the RDA, which would take place, start sometime in 2021, and it would go through this formal review process. And we'd love, before this process starts, to again look to get a third co-chair. So just to give a brief example of data granularity and the topics we're talking about, and Raina gets credit for this slide. It's from her work. She works for Ocean Networks Canada, and she put together this example to talk about what do we mean by data granularity. So the research scientists that she works with go out on cruises. That's one type of unit of analysis that you can measure. The cruise has several dives. The dives collect information in various different formats and structures: video, temperature measurement, physical samples of sponges and sediment. Those can go into individual files themselves, and the individual files themselves have particular data points within them that you could slice a single data point, all observations on a particular topic, a single observation on all topics, and that there are various different ways that her organization works to try to keep track of their data sets using persistent identifiers and DOIs, and yet is the infrastructure set up really well to deal with all of these levels of granularity? And those are the questions that we're asking. So I'm just going to give a very brief 2-page sort of slide summary of the case statement. Again, you can read it yourself. The idea is that we will continue the work of the task force and everybody who's been thinking about this to explore key questions, to develop both use cases, and the specific outbooks would be a collection of use cases similar to the ones that Fotis had talked about before for the other projects, and then a guidance document of data granularity approaches for how you can deal with data granularity in a number of different realms. And if you think about all the areas that RDA deals with, discovery, metadata, repositories, data granularity touches on all of them. So key questions thinking about how that data could be stored and referenced, what are the relationships, and what are common terms for granularity. You know, if you go back to this example, Raina said an individual data file could be called a granule, but some people might use the word granule to mean something else. So can we get common terminology so when we're working on infrastructure, we can make sure to not have something fail at the last minute because of different terms. So the specific work plan that we're thinking about is collecting use cases, identifying constraints in the structures for how various different aspects of data infrastructure, such as registries and metadata standards, deal with granularity, collect more information by surveying the user community, and then writing up the guidance paper as well as the use cases. And as part of all working groups, you want to be able to solicit feedback as you're doing your work. So that would be part of the process. So next steps are I really encourage all of you to review and give your feedback on the case statement. And you will have many chances to review this, but this initial wave, we're asking for information back at the end of November. And we'd love you to come to our session, and coming to our session, we'd love to have you come to our session to think about participating in our working group. And I really encourage you to come tomorrow. We're not going to say you have to decide whether to sign up tomorrow, because people are dropping into various different sessions in RDA. You're experimenting, you're seeing what would be of interest. So do drop into ours, find out more information, contact Raina or myself. And I could take questions now, or we could actually do that later in our discussions if you all prefer. So thank you for listening.
Thanks, Katie.
So
That
chairs,
was
would you like to
awesome.
take questions now or later?
So we will have a breakout session
Yeah.
dedicated for that at the end. But
Okay.
I would also encourage, if there are particular questions to Katie that we can address them here, so that everyone is sort of present. Otherwise, if the granularity sort of breakout would be more targeted there.
And so, I haven't been monitoring the chat, so I don't know if there are any of them.
I've been looking at it. There's no. So there is one point here.
Came in from Ian. Yeah. The fundamental idea on a granule is that a granule is a node in a directed acyclic graph. Of course, that's very technical, but at the fundamental level, it allows for anything. So a node in an acyclic graph, right?
So Ian, I don't know how. Sorry, I came into the meeting late, and I've
welcome.
Involved in the question for some time in different ways, and you know, going back to the NIH Data Discovery Index, and so been working this for a while. But you know, to me, there's a basic fundamental thing there that if we can get to, it kind of solves all problems. But
wouldn't that be great?
But there could be a long step, right, from where people are to getting to that point, and that different people are at different places along that. And even, you know, I loved your example, right? I'd never seen that before, but it's exactly the same concept that when we talk about DICOM medical images, right?
Yes. And I told Raina when she had said, should we have examples from different fields? The concepts are the same regardless of your field, I think.
The thing that would be common to us, and I want to say, is you need you need a graph for yours, and we need a graph for ours. But our graph is never going to be harmonized with your graph because we're defining a different world. So we have to let those worlds define their graph, their structure, but have a common way in which we represent those graphs. Because I can think of, you know, might there be some reason that I would need to know something from a dive? Let's say that somebody went out on an oceanographic vehicle and they found some organism that somebody extracted a molecule from that cured cancer, right? Then I need to understand your graph to compare the effectiveness in curing cancer of this that was captured on this dive versus on this other dive.
Yeah, so those are great questions, and do keep sort of thinking about those. And if you'd like to be involved, we'd love to have your involvement. And I think you bring up a good question about, you know, what, in terms of how big of a problem this is, part of the working group process is really thinking about what's achievable in 18 months and what do we want to focus on. And also, I think the other question that you bring up really well is what, I think for RDA as an organization in general, what is the appropriate level of commonality and sort of building blocks for all different groups that they can then customize for their own context? So those are some themes.
There's another thing in relation to the granularity thing, which is a completely different approach. And I don't know where data discovery and what we're calling data discovery has got to. But in that approach, you set a very strict cutoff on granularity and you police it. And you say that our data discovery index is doing no more than getting you to the point where you can identify a data set that's going to be of relevance to you. Because, I mean, and when we did the data discovery index, that was the difficulty that we had, is that everybody wanted to go to what they were calling cohort discovery, right? Yeah. They wanted to reach all the way down into the graph and discover the individual patient or patients that had these characteristics.
Yeah, so those are a
much harder problem than saying, get me to the data sets that have something about colon cancer.
Yeah, so I think those are good questions, and let's keep talking more at the time later. I want to make sure to give the time to the next presenter. I will just quickly comment in the chat regarding where my slides are. Maybe they're in a folder, but maybe they're not in the correct folder, so I will follow up on that. And then Edgar Vega asked a question about granularity could be a group of metadata. So I think yes, in two different ways. So one is metadata is an aspect of granularity in that you need metadata elements aligned with the different levels of granularity that you have in your data. And maybe there's also an aspect to think about the granularity of the metadata itself. So I think that's a great question. So should we sort of defer other questions to later so we can have time for the next presenter? All right,
Thanks,
thank
Katie.
you everyone for listening.
Thank you, Katie. And just to highlight 2 points. So one is that the data granularity BOF is going to be tomorrow, same time, basically. And a lot of the points that Ian and Edgar sort of raised in the questions, or implicitly raised in the questions, are things that are sort of addressed, or aims of the granularity as they are of the granularity working group as it's defined right now. So your perspective would be very, very much appreciated there. So I would like to echo Katie and really, really encourage everyone to join that one. With that, I will move on to the next section. So if I were to share my screen just for a sec. Our next point of the agenda would be to aim for the second activity that we are sort of investigating at this point, which is the study of the user data search activities. And under this scope, we have two speakers today. One is Felicitas Löffler from the Friedrich-Schiller-Universität in Jena in Germany. And the other one is Brigitte Matiak from JESIS. Both of them, I'm very, very happy to have them here. And I will start by giving the floor to Felicitas. I don't know if I'm pronouncing this correctly. My apologies for butchering that name. Can you hear me?
Yes, I can hear you. Hello, Fotis.
Perfect. Hi, thank you for being here. I share my screen. So the floor is yours.
So currently I cannot see your screen. Give me a second. Because I have problems with my screen sharing. This is why I asked Fotis to share his screen. But currently I cannot see the screen.
I can see Fotis's screen.
But I still have this old agenda today slide on my screen here.
I can stop sharing and start again. This should somehow resolve this. Like, give me a sec. I'll stop sharing and I will start sharing right now again. And I'm doing the presentation.
Yes, this is the right presentation. Okay. Yeah, perfect. Thank you. So,
sure.
Yeah, thank you for the invitation and the possibility to share our research results with you. My name is Felicitas Löffler. I'm a PhD student in computer science at the University of Jena in Germany. In the next 10 minutes, I'm going to talk about a user study we conducted to figure out what biodiversity researchers are interested in when looking for data. So the overall aim was to identify main search categories being relevant in biodiversity research. Yeah, next slide, Fotis, thank you. Yeah, so at first I'm going to introduce a question corpus we had established over 2 years in several biodiversity projects. Second, I will also explain how we analyzed and evaluated the corpus. And third, finally, I'm going to report on the results and the identified categories. Next. Yeah, at the beginning, a short motivation why we are doing that. Our research group is involved in a variety of biodiversity projects with a strong focus on data management. For instance, we are part of the German Federation for Biological Data, GFBio. We are also part of the German Center for Integrative Biodiversity Research. And in all these projects, data discovery is increasingly important as data reuse, of course, is getting more and more important. Next slide. Yeah, scholars' information needs are very diverse. They are as diverse as data, as diverse, complex, and heterogeneous as biodiversity data. Information needs can be very specific, such as do butterflies occur on calcareous grassland, or they can be broader, such as how does agriculture influence the groundwater. So next slide, please. So in a first step, we collected questions. search and research questions. So the overall idea is to categorize the various information needs of data seekers. So is it possible to categorize that into a limited number of categories? And the second question was, can we finally structure the information needs? You need to click. Yeah. Okay, in the next slide. Yeah, so at first we collected questions, search and research questions in 3 biodiversity projects over 2 years. So we either sent mails to colleagues or we collected them explicitly in a session, at a workshop, or at a conference. Here on this slide, you see 3 example questions. In total, we had a corpus of 169 questions. We explicitly asked for search or research questions as we didn't want to narrow the scope. You know, scholars are familiar with search engines, and they know that a machine can return a good result when providing a few keywords only. But with a few keywords, you cannot capture the whole context. And with that previous knowledge, people tend to be biased and tend to provide only a very specific search questions. And this is why we try to broaden the scope. And we also offer the opportunity to provide research questions so that we get a deeper look into a researcher's actual information need. Yeah, next, we manually labeled the noun phrases and we try to categorize these terms. So this is what 2 authors of this study did, and we ended with 13 categories, and we discussed that in several discussion rounds. Here on this slide, you can see all these 13 categories. Most of them seem to be obvious, but some of them might need some explanations. So species and environments, for instance, have some certain characteristics, such as traits and phenotypes, that can be observed, measured, or computed. And these data parameters are summarized with that quality and phenotype category. And in our manual inspection, we also noted that a lot of scholars asked for a specific outcome. So a lot of people wanted to know, based on a research method, what is the they expected data sets of a specific type based on a research method. And this is why we created an own category data type. And events, for instance, as a third category to highlight here, are processes that appear only once at a specific time, such as environmental disasters, or for instance, events such as the tree of the year. Yeah, next slide, please. Yeah, once we had all these identified categories, we wanted to know if they are comprehensive and valid. So in particular, we wanted to get intuitive feedback from scientists because search is an intuitive task. However, the standard way of entity labeling and categorization usually needs a lot of training and guidance. Yeah, and when creating a gold standard, experts usually get annotation guidelines, what to label and how. This is presented in the left part of the slide. So this process is very time-consuming and not very intuitive. And this is why we decided to shorten it. So we, 2 authors of the paper, did the labeling and identified the terms that needs to be classified. And the annotators only got short instructions about the categories, and they were only asked to classify the terms. Yeah, next slide. So we set up an online survey where every expert had the opportunity to stop in between, to save the intermediate result, and to go on at a later time. We also told them not to spend too much time on a term because we want to get intuitive feedback. If none of the categories fit, they were able to provide an own category, which is denoted with that other category at the end. And if they didn't know a term, they were also able to omit the term, and we counted that as non-category. Finally, 9 domain experts took part. Most of them were postdocs with backgrounds in ecology, botany, zoology, microbiology, or geography. Yeah, let's come to the results. Yeah, next slide. So all experts classified these 592 annotations. The average annotation time took around 3 hours in average. So this is a lot, but still it's less than a training and a labeling session. So we analyzed the results based on 2 metrics, frequency and agreement. Frequency tells you something about the importance of a category. The more often a category appears, the higher is the interest. And second, we analyze the agreement. That means if the experts share the same understanding of a category. This tells us if a category, back please. Yeah, this tells us if This tells us if a category is missing or needs to be renamed. So at first, let's have a look at the results here at the frequency. So here we see that all categories were used. Although they were categories that were rarely chosen, there was no category that was not used at all. So the categories environment, organism, material, quality, process, location, and data type were or have been selected most frequently. We set a threshold here at 15%. However, what we also see is that the values for the category other and none are very high, and this might have various reasons. So that one term could have been terms could have been unknown to the annotator. This is one reason. A second reason is that phrases that refer to data attributes and which were supposed to be covered by the category quality were classified as other. And as alternative category, the annotators proposed parameter or data variable in a comment field. This is why we decided to add these ratings to the quality category. So the results for the other category then slightly decreased. This is denoted in these dark blue bars in the figure, and it's labeled as quality correction. So that strongly indicates that renaming the quality category or adding synonyms would increase comprehensibility. So now next slide, please. Now we come to the results of the agreement. We computed the agreement or the consensus with Fleiss kappa and Goetz AC. Both metrics are coming from statistics. The references are provided in the paper. So usually kappa values vary between -1 and +1. Here we obtained a Fleiss kappa of 0.49 and a Goetz AC of 0.52. So that means the agreement over all category was moderate. However, for a few categories, the agreement was excellent. So for instance, for time and organism, they are very good, which means, yeah, temporal information and species are easy to identify. The results are intermediate to good for the categories person and organization, location, process, materials, and environment. The experts agreement for the other categories was fair. This lack of agreement could either point to a different understanding of the categories or might indicate that the categories of the phrase itself was difficult, since some phrases, in particular the longer ones with nested entities, were very fuzzy and difficult to classify into one category. So next slide, please. Yeah, to sum it up, so what we figured is, what we figured is that 7 categories got a moderate agreement, and 5 out of these 7 were also mentioned very often. So we conclude that these classes are important information needs in biodiversity research. However, the categories quality and data type got fair agreements, but are mentioned quite often in the search questions. So we think they should not be neglected. We provide the entire corpus as a CSV file. We also provide the annotated corpus in an XML file with all category ratings above 0.6. And everything is publicly available in our repository. So next slide. Yeah, so in this talk here today, I only focused on the very first part of the paper, the user study and the analysis of the questions. However, we also explored if the identified categories are reflected in metadata fields and common metadata standards, which is part B of the paper. And in a third part, we also analyzed whether the actual metadata, so the instances use the metadata fields and how they are filled. So we really downloaded metadata from 5 large data repositories. We checked how many fields are used. And in a content analysis, we also explored the contained keywords. Yeah, last slide. Yeah, all scripts and results are publicly available in our GitHub repository. And yeah, thank you for your attention. And now I'm open for questions.
Thank you, Felicitas. That was really, really interesting. Before, let me check. Let me stop sharing for a second so I can sort of see the chat window. So are there any questions for Felicitas first?
I'd like to ask a question, but I don't know how to raise my hand.
I can hear you. That's fine.
Oh, yeah, I know, but I may be interrupting whoever raised their hands. I've worked a lot with lots of groups of people and biodiversity situations, and they're also interested in interactions. Okay, I've worked with plant-insect interactions in particular. So did these questions on interactions between animals and their environment, animals and plants, plants and plants, did they also appear in your study?
Yes, exactly. They did. So when you have a look at the question corpus in our public repository, the questions are publicly available. Yet then you can see that there are questions where people really ask what are associated taxa, or they ask for species occurring on a specific habitat. Yeah, this indeed is the case. Yes.
Thank you.
All right, awesome. I also kind of have a question, mostly just to ensure that I got this correctly. So this is really, really interesting, and I particularly like the fact of this between the frequency that the term appears and sort of the agreement. I am a bit curious about these broad terms. Let me actually share again the slide so that it's easier for me to sort of point out what I'm not doing full screen again for the same reason. So I'm looking at these terms, and I see that some of them are very, very specific and meaningful from a human perspective. So time and location, for example, are easy enough to identify as a human being on one hand. On the other type, we are talking about things like process or anatomy occasionally, and anatomy also have a side note later. They might be a bit more broadly interpreted. But when you look at these aspects, it appears that, not this one, time is indeed very highly in agreement. Location is not as much. And I'm curious why this sort of happens in the first place. Does this
Well,
sort of,
yeah, so it was very easy to identify time and temporal information in species. Yeah, 9 biologists were able to identify this is a species, and they were also able to say this is a date or this is a time. Some locations might have been also a little bit fuzzy. Yes, I mean, a little Atlantic Ocean, for instance, is clear, but if it's more a description of a habitat, something where not all people are familiar with, then this is maybe a reason why it drops a little bit. Yeah, so we would need to have a look at the individual results to see why location is not that high as expected. What we figured, for instance, also is a difference between these longer phrases and short phrases. I couldn't have the time to put that into this 10 minutes here, but it's in the paper, because we had longer phrases with 3 terms. They were more difficult to classify and more fuzzy. But when we had phrases to label with 1 term and 2 terms, it was the agreement increased. For instance, what was also interesting for us is to see that the processes, that biological and chemical processes, mostly appear with 2 terms. Yeah, so these are for us very interesting results. So that's worth to have a look into the individual results.
All right, that makes sense. So the side note that I was aiming for is about what was that? About the anatomy parts. So come from a life science background, but life science sort of field of the background. One of the key aspects that sort of is constantly emerging is that aspects like descriptors, even aspects like male and female, tend to have very different ways of being inserted as information as fields in metadata in different records. So I'm wondering if an ontology is used, and this is even more evident in the process, because in life sciences you can use, for example, the gene ontology, and a lot of the process there can be modeled across those terms. So my question is, would it make sense to connect this process to an ontology and use this as the basis to make more efficient?
Exactly. I mean, this is what we did in our follow-up application in this biodiff tagger. So we developed a text mining pipeline and we linked these categories to ontologies, to at least parts of these categories, to identify these terms with ontologies. This is what we actually did for the categories where ontologies are available. Not for all categories, ontologies are available, but for the ones where there are vocabularies, we did that. Yes, and we also, when we started designing these categories, we also had a look into existing work. So there is, for instance, also a +1 paper by one of my IDIF colleagues who developed a metadata schema for ecology, and all these categories have been also discussed with the people involved in there. So it's not the case that we started from scratch. So we also had a look into vocabularies, into metadata schema, what is already available.
Okay, awesome. Thanks. So I'll stop sharing this screen and I'll restart sharing my other screen. There we go. Well, instead of doing that, I will share. Thanks again, Felicitas, for this very interesting presentation. So I'll directly pass on the floor to Brigitte for her talk on data seeking in the social sciences, and the floor is yours.
Yes, hello, I'm Brigitte Mathiak. I work at GESIS, which is the Leibniz Institute for Social Science. So I work a lot with social scientists and how they are looking for data. And this is how this all came to pass. I also need to mention my co-authors, Thomas Kremer, who's writing his PhD on this topic, Jelko Karevich, Dagmar Kern, Andrea Pappenmeier. We're all working at GESIS. So in a way, this is actually funny because we didn't plan this, but it's kind of like a follow-up. So we assume that people already have research questions. And what we were interested in is, okay, here we go. When they have this research, we wanted to make some sort of experiment to see what they do with this research question in order to hopefully at the end get a data set. So basically what Fotis showed earlier, the process from the user and how in the end they will have the research data. So what we did is we recruited 12 social scientists from advanced PhD students all the way to professors, male and female, also with some sort of variety into what they were doing, some political scientists, some more statistics focused people, and so on and so forth. So we have some diversity to cover most of social science. And we were asking them, in the context of your research, you need research data. For today, you decide to start with a search for that research data. And then we would, basically sit behind them with a camera or a screencast software installed on their computer and just observe what they were doing for about half an hour and see what was going on there. We recorded that, and we asked them to think out loud what they were doing, why they were doing certain things, to explain to us what they were doing. And also later on, we would make something like a semi-structured interview where we would go back to what we'd just seen and ask them a couple of questions about that. So this is how this looks. This is a video and it's very quick. So this is how people search data, in case you've never seen it. At least social science, you probably have never seen a social scientist do that. As you can see, there's, and this is why I thought it was so important to let them do that on their own computers, because as you can see, they're now opening PDFs. We have people who have been calling colleagues on their phone. We had even one person who just, went to the office next door and asked a colleague. This was before Corona, obviously, and so on and so forth. So you can see people were really looking at a lot of different websites. This, for example, is a website that is only laterally relevant for data search, you might think. Okay. So what we do with this information, we use a technique called Affinity Diagrams. which basically starts with transcribing. So what was our data? So we had the voice recordings of what had been said. We had the observations from the screencast. So basically, whenever they entered a new area of what they were doing. So, okay, now this person is, opening a PDF. Oh, now they're at this sort of website. Now they're at this sort of website. We would take a note in the transcription, and of course we transcribe the interview as well. Then, and this is part of the Affinity Diagram methodology, we put it all on sticky notes, and all 5 of us would just try to sort these sticky notes together to see if they would give clusters. And this is how this looks like. We actually had I think 6 or 7 of these really large pieces of paper with all these sticky notes that would again cluster together on several topics. And we'd also have to go through it several times because at first it just didn't make a lot of sense. Okay, so this is what we did. And what did we find out? First of all, I'd like to start with the clusters. So obviously, it all kind of revolved around data set search, but there are certain things that we observed about the context that people were in. For example, what did they know before? There were some people that were saying, okay, I'm looking for data. Okay, I already know 3 data sets that might be relevant off the top of my head, and I just go there directly. Other people, like the PhD students, they had no clue at all. They would just start from 0. Then, of course, we had all kinds of different topics, and that, of course, made things very different. If you're looking for statistical data, it's different than if you're looking for survey data, and so on and so forth. And also, is there already a big data source that everybody uses? These sort of things made a huge difference. There were some basic strategies that people had. For example, one person was saying like, "Oh, I'm always looking at the institutional website of the data set that I'm looking at just to see what kind of people have made this." And also something like, do I have colleagues? How involved are my colleagues into this? How do I use my colleagues to gather certain informations and networking? How do I use my network? Of course, the professors would use a lot more networking than the students. The other thing that we saw that there were a lot of different resources. It surprised us a little bit because in our mind, we had actually a very similar image to how data search was supposed to work as the one that Pucci said. So you have the user, you have the data portal, and then you have an arrow between the two. But this is not really what we saw. So there were a couple of things that were really weird. One of them was that people used Google really a lot. Then, of course, they did use the portals eventually when they found them. And of course, something that we hadn't really thought about that much as well was the interlinking. So you would want to go from the data set to maybe a related data set. You want to go from the data set to the documentation that is relevant for the data set. You want to go to literature, everything like that. So you would actually not like, oh, I have a need and then I find the thing and then I'm done, but you enter this network that you want to work within. There's also the thing like, how do people actually work, which was interesting. What do they even consider a result, which is not as clear cut as you would think when you come from literature. So I usually do this for publications, and there you go like, okay, this is the result list and this is relevant, this is not, a blah blah blah, and then you really quickly weed out stuff. But this is not really what happened there. So that was interesting as well. We had a lot of people that were trying to compare two data sets, which is also something that we hadn't really thought about. And we also found some interesting things of how people would try to remember what they had already been looking at and how to organize this sort of information. And then there was like a huge block, and this was really because people that spend a lot of time doing that is just trying to assess if this is really the data set that they're looking for. One of the big obstacles obviously is data access. So they would find a data set, they would find it interesting, and then boom, they can't get it because it's restricted. Then you would have the whole question of relevance. Is this exactly what I need? it's usually not that clear cut. So people would spend a lot of time just trying to figure out if this is a data set that they can actually use. And also, they would spend a lot of time on trying to assess if the quality is good and what kind of problems there might be with the quality. So these are really the things, and this is all before they even start working with the data set. So there were a couple of people that were diving just right in and say, okay, and now I'm trying to, you know, crunch the numbers and stuff like that. So we kind of cut them out there. So this is really just to decide, is this a data set that I want to be working with? The other thing that we did, which I thought looked very good. So this is also based on the same affinity diagrams, but a different visualization of that. So I mentioned earlier that every time people entered a new area inside their web browser, a new activity, we would take a note of that, make a note of that in the transcription. But then we also had the idea, okay, maybe we could just visualize that, just that information. And here's what you can see for that visualization. You can see that, well, almost everyone starts at Google, and also they go back to Google a lot of times. So they have Google, and then they do a little bit, and then they're dissatisfied, and they go back to Google, and so on and so forth. This is a very, very common pattern that we see. They don't usually spend a lot of time there, but they start over again in various parts of the process. Then we have okay, so then we have something like study or project websites, which is the purplish one. And this is also something that people would go for. So if you enter Google, you don't always just land at the data portal, because a lot of data portals for some reason don't have a particularly high page rank. Sometimes you find other sources for data, and then you have to go there, and then you have to find the link where it's the download, and then you go to the data portal, and so on and so forth. So this is something that goes on. So just to explain the first line a little bit. And then you look at the documentation to figure out it's not the right one, and then you go back to Google and so on and so forth. So the other thing that I found noteworthy is that if you look at the box color for data download, which is very, very light, I would call it a pink maybe, there's only 5 of them. So we had the 10 participants, and only 5 times in this half-hour segment for 10 people. So on average, there was half a download per session. So 1 download per hour. This is, of course, bad math, because people were very, very different on how, and sometimes they went to the download place and downloaded 5 at once, just because that was they wanted to look at all 5 of them. But this is just to give you an idea of how complex and time-consuming data search is for social scientists. And the other thing that we were somewhat surprised at was the amount of blue. So blue is Google Scholar. Blue is the slightly lighter blue is looking at full text, and the even lighter blue is looking through a library portal. And as you can see, there's a lot of blue. And of course, you know, I come from literature search, and I was surprised to see that back there again. But of course, it is a fairly efficient method. So you look at other papers, see what kind of data set they used, and then you look for that data set, which is in many cases a lot quicker and more efficient, and it also than going through the data portals. It also has the benefit that if a lot of publication uses certain data set, you already know that it's established in the community, so you can be sure that the quality is up to par. So we did arrive at some key findings. So number 1 is literature search is an important part of dataset search. One of the questions that we asked them is in the structured interview is how were you made aware of a certain data set? And all of them said, oh, I read an article, that was the name of the data set, that's how I knew it. So obviously you could choose multiple outs. And so combined with the results before, I think that's really clear, you know, that literature is a really important part of that process. The other thing is just the general message here that data search is really complex and difficult for people. And especially the relevance assessment. So relevance assessment is really time consuming, and people sometimes actually crunch numbers just to be sure that the numbers add up. So for example, if you are comparing two data sets, you actually have to use math to figure out if they're comparable. And this is just to choose whether whether you want to do this comparison or not. Okay, and so this is my list of 7 most relevant findings. Another thing that I observed is that, you know, working at Jesus, we have, I think, like 5 or 6 tools just for data search. And it was very apparent, and also it was painful for me to watch, that they didn't know them. They just didn't know them, and they didn't find them either. So they had this information need, and I knew that there was a tool out there that would have fit perfectly for them, but they had no idea it existed, and they didn't use it, and they didn't find it via Google as well. And this is the one that kind of pained me the most, because we spent a lot of time and effort to design these tools, and then they just, you know, it doesn't really matter. They're not there when they're needed. The other thing, which is kind of like the reverse thing, is that people found really surprising solutions to information needs that we never had thought of. So for example, one participant had the need to find a person which had already worked with a data set. So he was saying, okay, maybe I know someone who has already worked with a data set, who works either at my university, or, I mean, this was a professor, so he had a lot of experience. And I just, when I saw the screencast of that, I was like, okay, really? How are you going to do that? And it took him 3 minutes. He just used Google Scholar and really, you know, doing nifty stuff. And then and he actually did that again, but with ResearchGate, which also worked really easy. So it was like, oh, okay, yeah, okay, this is an information we never thought of, but we don't have to make a tool for that because it's not a problem. Then, of course, we have this problem. We saw this a couple of times, that accessibility to data sets is limited. Again, for some domains, it was more important than for others. This is, of course, a problem. Everybody knows about that. But the other problem was that a lot of times you would really have to click a long time before figuring that out. So it was almost like, you know, clickbait. So you'd spend 20 minutes to figure out about this data set if it fits your needs, and then you go like, oh, okay, I have to pay for it, or oh, it's not available yet. It's under quarantine. Okay, I can use it in 2 years. No, that was not very good. So this is something that people should maybe thinking of. And also we saw that people, I mean, a lot of that was compensated by being really creative. But there was, for example, one information need was, okay, I have this data set. I want to know people who work with the data set. And the easiest way to do that is to find publications where these data sets are mentioned. So what you do, you go to Google Scholar and you type in the name of the data set, and hopefully it's a good name and not something like life and health, which is of course completely useless as a search term in this context. And then you look at papers, and then you can kind of like narrow things down. But oftentimes it seems like, okay, wouldn't it be nice if someone had already done that, and you'd have just have a link and say like, okay, and these are the publications that talk about the data set, because it's really common information that people had. And the other thing, and this is like number 7, is that people didn't really know what they were doing in a way, even the professors, and they often articulated that as well. They had never really, I mean, when you're a student, at some point you're invited to the library, and, you know, people show you how to find books and how to find articles. But with data search, it's a lot of trial and error, and people are just trying to make the best of it, and they feel kind of uncomfortable about it because they know they're probably not doing it right, but they don't know how to do it right. And this is also something that that we did observe a lot, and so we wrote that down as part of our most relevant findings. Okay, so this is my last slide. I thought 10 minutes, 10 slides. Do you have any questions for me?
Thanks, Brigitte. First of all, it was really interesting presentation. I kind of have a few questions, but there are already a few on the chat.
Oh, okay.
So I'll start directly by Ming Fang. Did anyone search from within a data repository or a data catalog?
Okay, please. I was trying to look at the chat. Come again, please.
Right. So yeah, did anyone search from within the data repository or a data catalog?
Yes, this is what happens. So they would use Google to find the data catalog, and then they would also search within the data catalog. This happened. And sometimes it was a little confusing because many data catalogs had like multiple search, multiple ways to search it. But yeah, this is absolutely something that did happen.
Are we talking about the same thing when we refer, because Google even has a data set cataloging exercise, right? Which you're probably aware of, but it's not
Yes,
Google.
I am aware of that.
Right,
yeah.
but it's separate from Google Scholar, I think.
Yes.
And one of the questions is why isn't that where people are going when they want to find data sets?
Because they don't find it and they don't know it exists. This is rule number 3. They have they have no knowledge of it. And we actually this is one of the things that I've been talking about. They didn't know it, and it didn't pop up in the search queries that they typed in, and so they didn't use it at all. None of them.
Sorry, go ahead.
That's one of the, of course, the goals of the schema.org task force working group is to improve the way data sets are marked up so Google data search does find them, and that people who type in a name of a data set or keywords that describe the data set, the general Google search, I mean, you don't have to go to data search. It will be part of your general search results if there's a good match. So that's one of the purposes of the schema.org is so that becomes more a more easier way to find data sets, a more universal way that people look for data. It's not that widely known now because clearly it doesn't, not everything is marked up in the way that makes it possible for Google Scholar to index it.
So in this particular case, I know for a fact that the schema.org was there and that it was rich because I put it there. So they were looking for data sets that we had in our data catalog. And there was no Google data search at all. We never see it.
I have the same experience for data sets, that they are indexing half of what we're having, but not the rest. So it must be something odd still with the algorithms, I think.
No, we actually do know that they have indexed all our data sets. Sometimes even multiple times, which is kind of weird. But we do track that if they have it, and we do know it's there. And in particular, the data set that they were looking for would definitely and Google data search at that particular time. Yeah, but yeah, that's.
But we can't just put the responsibility for that on Google and say, they didn't index us. That we have a role in that. One of the things when we first started talking as part of the NIH Discovery Index with schema.org was the big success. They tried various things, and the big success they had with schema.org was because it was supported within content management systems, which meant that nobody had to think about indexing their data. They just used a content management system. and schema.org picked up off what the content management system was doing. So the experiment I tried was to use a content management system to plot a graph and to index it automatically through the content management system to say, what was that graph about? Now that still shows up in data set search. And I didn't have to do anything other than plot a graph, and it became indexed. So it's that's the kind of, in their original schema.org, that's where they kind of got the leverage from, was that data was automatically getting indexed. But we've, I think we haven't got to the point where we're leveraging that capability potential.
Yeah, so there's also, like, you get error messages. So and this is not part of the study at all. It's just something that I've been working on the last couple of months, which is kind of independent. But for example, if you go into Google Search Console, you get error messages as to why certain things are indexed and others aren't. And once we figured that out, we could also really increase our user numbers and all kinds of things. And we would be a lot more findable in this sort of terms. But this is not, I mean, I'm not here to teach you search engine optimization, but there are ways around that. So not being indexed by Google is not a fate you have to accept. It's I think it's actually the contrary. So it's a bug that's somewhere in your system. You have to find it and fix it and squash it.
All right. Awesome. I'm very, very happy with the discussion, although I know that we are running but a lot late than the actual agenda. I think that the discussions so far are quite interesting, and it would make sense sort of to move things forward faster than actually needs. So thanks again, Brigitte, for a very, very interesting presentation. So I'll move on. Let me start sharing my slides again.
So do you want me to comment on a couple more of these? Like,
well, that is sort of my my next point, because so according to the agenda now we are supposed to do 3 breakout rooms, which were supposed to run for 30 minutes, but we are 15 minutes to the end. So my question here would be, the breakouts were for Granularity, breakout 1 for the user studies, and what Brigitte and Felicitas actually talked about for breakout 2. And the third breakout would be for additional topics, new task force, and so forth. Given that there is a lot of interest already in the things discussed, I propose that we sort of skip the breakout rooms and spend the next 5 minutes discussing about comments that you would like to raise, Brigitte, from what you've seen on the chat window, or any other aspects that we raised. And then we spend the last 10 minutes of the session for any follow-up actions and potentially additional topics for task forces that can be initiated within this work group, this interest group, sorry. Does this make sense? Good. Yes, please. Sorry, I thought I heard something. So Brigitte, did you see something in particular that you wanted to?
Okay, so I see Dorothea Strecker. Did anyone use registry of research data repositories like re3 data? That's a no. Yeah, it's a complete no. No one ever used that. What was interesting, a couple of people used university websites which list interesting services. And we did, for like a split second, consider writing to universities to include our services in there. But there are so many universities, I don't think that would have been very effective. Yeah, that is something that we saw. Read-through data, we didn't see at all. I don't even know how many users read-through data has. But yeah, that's something. So I wonder if there are relatively fewer repositories for data in social science. I don't know, John Graybill, I don't know what your standard is there, but there are hundreds of repositories for social science data. Jesus is one of the players, I would say, but we're not even the largest one. And of course, social scientists use also a lot of interdisciplinary data and also statistical data. So you have players like OECD, you have players like Eurostat, and of course now with COVID, also a lot of medical information on COVID data and all kinds of other stuff. So we usually call the landscape fragmented, and I could name dozens of data repositories in social science just off the top of my head. John, does that answer your question?
Yeah, yes, it does. I think it's comparable. I think what prompted the question for me, two things prompted it. One was I had in other contexts heard strong desire for social sciences to look into semantic management, more semantic practices. And then in your talk, I didn't hear I didn't hear as examples the use of searching for things by DOIs or by unique identifiers, which I just was putting that together. I was just sort of curious about what the general practices were and whether they were analogous to in earth sciences or biomedical sciences.
Yeah, so I'm not too familiar with, I mean, I read about these practices, but I've never really studied them, so I can't really speak to what earth scientists and medical people do. I mean, I did work in bioinformatics for a little bit, and PubMed was like really huge and central, and also would link to a lot of stuff. And we social scientists don't really have that like super hub sort of thing that from there on out everything connects to. This is actually, I think, part of the problem that you can't. There's not this like one authority, and from there you get to all the all the small things.
Right.
You really, actually, you kind of have to use Google just to find your way to anything relevant. Let's look at data sites. So I know for a fact that all our data does have DOI because I put it there. No, in that case, not actually me personal, but one of my colleagues, obviously. The problem is that data site is not useful at all for searching for data sets in the social science for the tricky reason of granularity. We have a lot of DOIs in social science, and we have a lot of duplicates, sort of. So when you type something in, even from a data set that exists in a data site, it's actually kind of hard to find it, just because there's so much spam, so much duplication, so much low granularity stuff that it just you can't see anything because you type in whatever you're thinking about, and then you're just wham so close to the data, and you see that. And I have to admit that GESIS is part of the problem. So we have this one data set which is called the Albus, and we have over 300 DOIs registered just for this one data set, because of course there are different versions of it and they're all sort of different. But in the end, when you look at a paper, that no one ever makes much of a differentiation. So people just say, oh, it's the Albus. And that's also part of the reason there's not a lot of data citations in social science, because which one of the 300 DOIs are you supposed to cite, right? That's a huge problem. And I could give you a 10-minute talk just on that topic.
All right. Okay. So I see that there is really a lot of side talk on the chat window.
Oh, okay. Sorry.
No worries. What I'm trying to say is that I've actually tried to capture everything on the. I'm copying everything on the minutes, so it will stick around even if we close the Zoom session. So for the last 10 minutes of the session, because I don't really want to go overboard, and I know it's getting late for a lot of people, I would like to switch back to a final part for the Data Discovery Interest Group. So switch gears a bit, if I may. I'll share my screen now and highlight a few of the slides here, which is this one. Right. So can you see my screen? Yes. All right. So the idea here is to present ideas from the data discovery kickoff meeting back in 2016, when we sort of bounced around ideas for topics that may be relevant under the data discovery paradigms interest group. So this all came from the community during that meeting. You see with green ticks, the ones that are already captured one way or another through task forces, through efforts there. There are a few that are still outstanding, if you like, including the cataloging common APIs, the duplication of search results using upper level ontologies, search personalization. So what I would like to ask here is, first of all, this has been quite some time since the 8. It's 4 years, and things have evolved since then. I'm not sure how much in the data discovery field, but still we've made progress. So for this reason, I would like to ask everyone your ideas and opinions on what, so first of all, on this particular 4 topics, whether these are relevant still, so that we can maintain them, and what could be additional points of interest that we may start considering as additional task forces. Are there any ideas around this group now? Or thoughts for that matter?
Fotis, are you sharing a slide at the moment?
Yeah, I see it. Right, it's just a list of the 9 topics from the original that were distilled from the ideas thrown out, the brainstorming done at the first at the kickoff meeting. So this was just to show what we've done. Well, recapitulate, since Fotis already went through it, the outputs we had generated, but the topics that we have approached, metadata enrichment. Got work done, but that was never produced an output. It kind of withered a bit, the effort, but it's still highly relevant. It just needs some people who wish to pick up that work and carry it forward. The duplication was already mentioned. It is clearly a problem that begs to be solved. I would say that so much machine learning, artificial intelligence now is coming into the process of data discovery that's something that's an area that some guidelines or common practices or state of the art sort of effort could be initiated on, but it would have to be focused on some particular facet of data discovery. Semantics clearly is being incorporated into data discovery on various levels. So it remains a relevant topic. Personalization, that ties into search functions that are being surfaced through the user studies. This was just the sort of the ideas 4 years ago. So I think there's a lot more that could be Next slide. There certainly is a lot of other things that might be pursued, and a lot of these actually are some of the topics are being looked at as part of other interest groups and working groups within RDA. I know the librarians are the librarian group has a session parallel to this right now, talking about how to share methods to improve data discovery. So let's hear it. What do people think?
Well, for sure, what is definitely true is that for the user studies and the data granularity, there is a clear interest. So it's excellent that both these efforts are moving forward. Judging from the chat discussions and the comments, everything is quite positive. the question is based on the, as Jota said, based on the on the field right now and how things are around the different RDA working groups, communities. What are the missing pieces? What are the missing aspects of that discovery that we need to address as issues, or we need to investigate more to have more information about? From my perspective, I still am in favor of aspects like the duplication of search results and search personalization, because I still tend to see all those aspects from the user perspective. I tend to be more of the, to fit more the user profile role rather than any other of the key aspects, key actors in the data discovery process. But this is really the reason that we open this discussion during every plenary session, to ensure that we capture any new ideas, any new instances, problems, issues that come up. So please feel free to unmute yourself and join in, or type it in the window. Yes, please.
Yeah, hi Photos, this is Felicitas. Can I just ask my question or give my comment, because I cannot see how I can raise my, yeah. So what I see here from the slide is that you have this using upper level ontologies in here. What is still missing, or what is still missing? Do you mean upper level ontologies in terms of connecting the existing ontologies, so linking the existing ontologies, or what do you mean with upper level ontologies?
So my understanding, yeah, go ahead.
Because this is what from my perspective is missing. So we have a lot of ontologies for different purposes, but they are not all of them are well interlinked with each other to larger, so let's call it knowledge graphs. This is what the semantic web community is currently working on, knowledge graphs, yes, combining and linking the existing vocabularies and ontologies.
So if I recall, at that time, the main goal was to sort of identify commonalities between ontologies that are widely used, so that you have a way of ensuring that the data discovery can work in the same process regardless of where you're coming from, which field you're coming from, and this sort of perspective. I don't know if it's an ontology of ontologies. This might go a step further, I think. But I think that's my impression of the time. I don't know that we've touched upon it since then. So your interpretation of that might actually be a better reflection of what is the actual state at this point.
Okay, thanks.
Yeah, Siri Jota, please.
No, I was gonna second that. That Felicitas does mention probably the appropriate direction at this point, because people are learning that ontologies are useful, and they identify the ones in their domain, and they, it's still kind of hard to discover. I mean, there've been efforts to, create data sites that data portals for ontology discovery and what have you, but a way of making them transversable across domains, and since cross-domain discovery is becoming more and more important as research becomes interdisciplinary. So how do you seamlessly align ontologies? And probably John would have something to say about this. He's thought a lot more about it than I have, and actually try to work on it. So do you think there's a topic there that could be pursued in a spin-off group?
Yeah, thanks. So we are right on the half-hour mark, and I know that we should be closing up shortly. So I only have a couple of closing comments. As Ming-Fang said on the chat window, the group has a monthly call on user studies for data discovery. So if people want to contribute to further discussions, they are more welcome to join. Feel free to join the data discovery interest group, and you will probably get the notification about those things. I would also strongly urge you to join the Granularity BOF session tomorrow, same time as today. where all the case statement will be discussed, and and the community feedback, the RDA community feedback, would be very much appreciated to refine this and better fit what are the needs. And of course, everyone is more than welcome to ping us with ideas about new task forces, issues or problems around the data discovery process that we can take into consideration. If we gather enough of an interest, we will also kick off a task force around this as well. So are there any other further comments, Srijoda, Mingfang, before we close the session?
I think that's it. Thanks everybody for joining.
Yeah, thanks everyone.
Great rest of your RDA.
And thanks a lot for the speakers. They were awesome, and their presentations were really, really, really interesting. Bye everyone, and enjoy the rest of the plenary.